Alright guys, so we're going to start talking about electrostatics. Okay, now you guys have done electrostatics in grade 10. In grade 10, we learned that electrostatics spoke about positive and negative charges, yes?
Yes.
And we learned some basic fundamentals about charge. And we're going to re-look at that before we look at what we're doing with grade 11 electrostatics. So the first thing we need to realize is that when we talk about electrostatics, we are talking about the study of different charges. Okay?
Yes.
So if we talk about magnetism, we're obviously talking about magnetic fields. If we're talking about gravity, we're talking about gravitational fields and those forces. This is also what we describe as a field force, or a force that acts over a distance. Remember, with electrostatics, two objects don't have to be in contact with one another. They can experience a force over a distance. So the three things that can exert forces over a distance are electrostatic forces, so positives and negatives, which is what we're going to talk about now. We also know about gravitational forces. So things like, we looked at Newton's law of universal gravitation earlier this year, yes?
Yes.
And those are two masses acting, exerting a force over a distance, yeah? And then the other one we're going to talk about is magnetism, where magnetism also exerts a force over a distance, also a field force. When it comes to electrostatics, we're going to look at the forces between the charges. We're going to look at the size of the charges, the distance between the charges. We're going to look at graphs. We're going to look at something called Coulomb's law, and then we're going to talk about net forces as well. To start us off today, we're going to say that electrostatics that we studied in grade 10 can be summarized as follows. That charges are either positive or negative, okay? If it's a positive charge, there's a shortage of electrons. Yes? Don't worry, I'll give you a chance to write down in a minute. If there's a negative charge, it means that there is a surplus of electrons. So for a positive charge, there aren't enough electrons to balance it out, and for a negative charge, it means we have too many electrons. Okay, so remember when we spoke about a neutral charge in grade 10, do you remember how we described a neutral charge? An equal amount of positives and negatives. So if we had a balance between the protons in the nucleus and the electrons around the edge, then we spoke about a balanced or a neutral object. If the object had too few electrons, we refer to it as a positively charged object, and if it's got too many electrons, we will refer to it as a negatively charged object. The main thing we must remember is that it's only the electrons that are allowed to move around. Okay? Okay, guys? Now, when we talk about electrostatic force, we need to look at the following. How can an object be charged? According to grade 10 stuff, we can use friction. You've seen me do the whole thing with the balloon in my hair, yes? We can use contact. So one thing touches something else and it becomes charged. I've done that with an electroscope with you. And induction. We spoke about induction in grade 10 where you bring a charged object near to a neutral object, and the charged object will cause the neutral object's atoms to interact so that you've got positively and negatively charged bits forming. The forces that charges exert on each other are called electrostatics forces. And charge is measured in the Coulomb. Okay. So, if we take two like, so if we have two positives, they will repel. If we have two negatives, they will repel. If you have a positive and a negative, they will attract. Or a negative and a positive, they will attract. Okay. Then, the strength of the force. The strength of the force between charges is determined by two very important things. I want you to think Newton's law of universal gravitation for a minute. When we spoke about Newton's law of universal gravitation, when we spoke about the forces between two objects that had mass, what were the factors that affected the force?
The distance?
The distance, yes, and the masses. So when we spoke about gravity, it was about the masses of the objects and the distance between the objects. If the masses was increased, what happened to the force? also increase. And if the distance was made bigger, what would happen to the force? The force would get smaller. You know, because the further away things are, the smaller the force is. It's the same for electrostatics, except instead of using mass, we're talking about charge. So the bigger the charge is, the greater the force, okay? But the further the charges are away from one another, the smaller the force. So those are the ideas relating to it. Okay, those 2 points. So when we talk about the magnitude of the charges, we say that the force is proportional to Q1, which is the first charge, and Q2, which is the second charge. Where F is the force, that's the first charge, that's the second charge. Okay? Looks a little bit similar, hey? Looks like something else we did. Okay. Now, the units for measurement, remember this stuff, guys? Remember it. Instead of talking about times 10 to the minus 3, we talk about milli. Instead of talking about times 10 to the minus 6, we use micro, and nano, and pico. I will give you a chance to write stuff down afterwards, okay?
Yes.
Right, so the distance between the charges says that if the distance of the charge is squared, I'm sorry, there's something wrong. This is not R2, it's R squared. I'll change it in a minute. Then we know that it's inversely proportional. Just a bit of useless or important information is that an electron has a charge of minus 1.6, a proton has a charge of plus 1.6, obviously times 10 to the minus 19. And then we're going to talk about an alpha particle, okay, but not right this second. And that's where I want to stop for now, until we pull it all together, okay? So that's all we've got time for right now, so we're going to go all the way to the beginning. We're going to take some stuff down, and then in the next lesson, we'll put those 2 ideas together. We'll put the ideas of the charges and their relationships to the force, and the distance between them, and the relationship to the force. We'll do that in the next lesson. Okay, thanks, Cameron.